Hello my good student, and welcome. This is Dr. Sirme. For this video, I wish to take you through a full Form 3 paper. That is a Form 3 mathematics paper. And to start with, I wish to go through the questions first. So my students, sit back and go through the paper with me. Section 2, where the student is expected to do 5. But for this case, being a revision paper, I will do the 8 questions. I will do the 8 questions. Question number 17 is matrices and application of matrices to solve simultaneous equation. Question number 18 is application of quadratic equations. Question number 19, a higher purchase. That means it is commercial mathematics 2, the Form 3 commercial mathematics. Question number 20, that is sequencing and series. Yup. 21 is vector. Good. 22 is formulae and variations. These are variations, yes. Question number 23, this is statistics. Yes, statistics. Then question number 23 continues with a graph, a histogram there. Then question number 24 again is probability. So my student, that is the end of the questions. The end of the questions. What you can do, my student, is to stop the video and attempt the questions before I do the questions for you shortly. Thank you very much. The first question in section 2, that is question number 17. These are questions on matrices. Application of matrices to solve simultaneous equations. For this question, what exactly the student is given is a pair of simultaneous equations. 5p plus 9q equals to 7, 2p minus q equals to 12. The student is supposed to solve for p and q. First of all, the student is directed to use substitution to work out, to solve this. So substitution, you look at the two equations, and the second one is easier to make a variable the subject. So like I can do q, I can make q the subject. So q, remember q can be on this side, it is 2p minus 12. Okay, so that is the first thing we've done there, and maybe the student scores a mark there. So by doing that, then we use q that we have already substituted and expressed in terms of p in the first equation. So 5p plus 9 into q. My q now is 2p minus 12 equals to 7. And by doing that, I just need to solve for p. That is 5p minus 18p, yes, minus 108 equals to 7. By working out, finally p will be equals to 5. And having worked out p, I can work out q by bringing 5 on that point. So it will be 10 minus 12. You get that? So by that, the answer 1, the contribution of the method 1. So for part A, 3 marks. Maybe in another case, you can be asked to use elimination. Yes. So, but we have used substitution. As easy as it is, my student, I don't think you have any problem with that. Otherwise, if you have a problem, kindly practice. Now, part B of it. We are given now the matrix of the coefficients here. 5, 9, 2, negative 1. 5, 9, 2, negative 1. In that order. Then, I'm supposed to find the determinant. The determinant is equals to the product of the elements in the principal diagonal, then minus the product of the element in the other diagonal. So minus 5, that is 5 times negative 1, that is negative 5, then minus 18. And that's how you get this 23, negative 23. Having done that, we can now go ahead to get the inverse of that matrix. For any matrix whose determinant is not equal to 1, if it was equal to 1, we could just take these two terms, interchange them. Then these two assumes different signs. But for this one, the determinant is not equal to 1. So the way we work out the inverse, it is 1 over the determinant, 1 over determinant, then the element in the principal diagonal as reverses, that is interchanges their whatever their position. This was -1, then -1 will be here 5. Then the other element in the other diagonal maintains their position but takes different signs. That is all that I have done there for 1 mark. Yes, again 1 mark. Having done that, now we are good to solve the simultaneous equation. Look at this one, my student. I think that this is all you need to know. That for you to solve a pair of simultaneous equation by matrix method, you just need to consider the inverse of the leading the matrix, the main matrix, multiplied by the matrix itself, multiplied by the matrix of the constant, the unknown, that is the variables. Yeah, the variables, equals to the inverse of that matrix multiplied by the matrix of the constant, the answers. Just that. If I'm able to do that, my student, you are halfway into solving that simultaneous equation. Remember, an inverse of a matrix times the matrix itself, you get a unit matrix. That is what I've done. Multiplied by PQ, yes, PQ. Then the whole of the inverse is here, yes, the inverse that I had before, and then 7 over 12. So the best way to do it is, first of all, multiply this. -1 times 7, I get -7, plus minus, that is 9 times 12. 9 times 12, 108. So that's how I get -115. Okay, remember this part is out here. The next one, how do I go about that? -2 times 7, that is -14, plus this is 5 times 12, 60, and that's how I get 46. Okay, this one. Then I open the brackets, and that would be the 1 over -23 times 115, I get 5. Then 1 over -23 times 46, I get 2. And finally, this matrix will be equivalent to this one. The two answers, 1 mark. Yeah, if I can have this one, 1 mark. The illustration here, 1 mark, that is 3 mark already. 4 mark, 5. Actually, I think the question was given more than enough marks. So that is solving simultaneous equation by matrix method. Not a very tough method to understand. Number 18, you're given a garden. This is a garden that belongs to Mrs. Motiso. And then it has a path, that is 0.5 meters all round. Given the distance from here to here, it's x plus 6, that is PQ. Then this one, you're given that it is 8 less. So the first part, question A, Roman 1, find the dimension of QR. Basically, it is Q, that is x plus 6 minus 8. And you have this. That is as short as that. It is x plus 6 minus 8 because it is 8 meters less. Then the dimension of the garden. The garden is what is inside. Remember, from here to here it is 0.5. From here to here it's 0.5. So the length of the garden will be the length of the entire path minus 1. 0.5, 0.5. And that is it. 0, that is x plus 6 minus 1. You get this. The meters. That is the length of the garden on itself. Where do we get 1? 0.5, 0.5. The same with the width. Over here, 0.5, 0.5. That is 1. So the dimension x minus 2, originally as it was x minus 2. Remember, that's what we got here. Then I subtract 1. I get x minus 3 and I get another mark there. Now, part B, the question you're given that the area of the garden is 105 meters squared. So I only need to do the multiply what I know. I know the length, I know the width. X plus 5 times x minus 3. This one. Once I have that, That's a mark. My student, because of my space here, I've just condensed this. So all you need to do is to multiply x times x, you get x squared. X times, yeah, that one you get negative 3x. Then you have this x and this, you get 5x. So if you are able to subtract this, you get 2x. Then you have this 5 times negative 3, you get negative 15. Negative 15, these will come back on this side and be negative 105. That's how you get negative 120. So by coming up with that equation, another mark. Going ahead to solve it, you get another mark for solving, and a mark for the method there. How do you solve that? Get two numbers. Their product is 120, negative 120. Then the sum is 2. So the two numbers, basically it is 12 and 10, or negative 10. 12 and negative 10. Then factorize and get it. So finally I disregard negative 12 because x represented the measurement. So I take this for an answer. And by doing that, 3 marks already. So the final mark is for substituting the values of x and get the actual length. The actual length here was 10 plus 5. That is x plus 5. You get that. Then 10 minus 3 gets 7. That was the width. And you get the answer there. So basically that is how you do that for a 4 mark. Remember we had 3 mark already. So that is 7. Finally, you are supposed to work out the number of poles that this lady needs to fence. Maybe some short poles that she needs to fence or to surround her piece of land. Remember the length is 15 meters by 7 meters. So the perimeter is basically 15 yes plus 7 times 2. 44. Yes, it is 44 meters. And if it is 44 meters, it means 44 meters multiplied by 100 to make them centimeters, divided by 10. So the number of poles that this lady needs, it's 440 poles. Basically that. Remember, my student, you need to go back to the question. Try to review the question. Okay, my students, we do number 19 together. The question to do with money. Money. That is commercial mathematics, especially hire purchase. And you're given that the hire purchase price of a PA is 448,000 shillings. And then a customer did a deposit of 112,000. Yes. The remaining amount of money the customer was to pay within 24 months. So the question A, determine the monthly installments. Remember something else you're given, that the cash price is 15% less than the higher purchase price. Now, what exactly do we do? For us to get the monthly installment, the total higher purchase price, subtract the deposit. And what exactly do you get? The total monthly installments. The total monthly installments. So, how much was being paid per installment? So, it is the total amount of money divided by 24. So, by working out that one, by working out this, you get another 1 month. So, you take the total amount of money to be paid for 24 months, divided by 24 months, you get that. That is it. Part 2. Determine the cash price. The cash price. They are saying it is 15% less. So 100 minus 15, you get 85. That is percent. 85% of the higher purchase price. And by doing that, the method 1 answer, you get 1. Now, we go ahead that this customer decided to buy this PA on cash, but he was given or she was given a discount of 8%. So this person bought it at 92%. So the 92% of the cash price, instead of giving this, the customer was given what we call a discount. So by working out a method 1 for just getting 92% of the cash price there, then the person decided to go for a loan from a bank. maybe to secure this PA, and this person was to borrow this amount of money, so that would be your principal. Then the money was to be paid at a rate of 16% per year, and the money was to be paid within 2 years. However, it was compounded quarterly. Yes, it was compounded quarterly. After every 3 months, it was compounded. So what does that mean? The rate per a quarter of a year is 16 over 4. That is it, 4%. The number of period that this money will be compounded will be 2 years times 4 quarters in a year. That is 8. So even as we use this formula, we know the amount is what we're looking for. Principal, we know, yes. Then the rate now changes to 4. The number of periods, compound period, 8. Then you substitute there. My friend, there is several steps I've assumed. Work them out and then get the answer. So this is the amount of money this customer could have gone back to the bank to pay, or the total amount of money he paid to the bank. Patsy, you are supposed to express as a percentage the difference between the amount repaid to the bank and the higher purchase price. So the amount paid to the bank, there it is. The total higher purchase price, the difference, you get it out there. So the difference divided by the higher purchase price times 100. You get an answer there. And of course, maybe the method there. So again, 3 marks. Okay, question number 20. Sequence and series. You're given that the first term of AP, so this one we're working with an AP, is 2. The sum of the first 8 terms, 156. So this is the formula for the sum of the first n terms of an AP. So don't mind, this one is in the mathematical table. At the back of the mathematical table, that one is there. Now, what do you need to do? Substitute what you have. The sum, you have it. The n8, yes, 8 over 2. Then 2a, yes, 2a. Then you have n minus 1, 8 minus 1 equals that. So after working out all that, you get the answer. You get the answer, of course, and the method, 1. That is it. I think that should be a 2-mark question. Then you're given that the sum of the first n terms is 416. So you work out the n. The same formula applies. N over 2. Now, in this case, we do not know n. Then 2a, that is 2 times a, 2 times 2. N minus 1 times 5 equals 416. Multiply by 2, multiply by 2, just to eliminate these 2 here. Having done that, work out what is in the bracket, open the bracket. Once you do that, you'll end up with this equation, quadratic equation. 5n squared minus n minus 832 equals that. If you solve this, you get the value of n to be 13. So the number of terms is 13. So my student, I'm leaving you to the task of working out that. Solve that quadratic equation. Part B of the question, they're giving us a totally different question here. They're telling us the third, yes, third, the fifth, and the 8th terms of an AP, another one. They form the first 3. They form the first 3 terms of a GP. Then they are asking us we find or we determine the first term of that GP. So what exactly should we remember? That if I have an AP, the first term is A. The second term is A plus D, the common difference. The third term is A plus 2D. The fourth term, for that matter, A plus 3D. The other one, A plus 4D. Okay? So we are talking about the third term. So this is the third term. So how will the fifth term look like? There it is. Okay? How will the 8th term look like? A plus 7D. There it is. But we know what D is. We know the value of D. For this case, D is given to be 3. So if D is known, it means the first term is, for that case now, the first term of the GP, a plus 2 times 3. There it is. 2a, that is a plus 6. The other one will be a plus 4 times 3, 12. There it is. And of course the eighth term will be the same, provided we replace d with 3. Having done that, these are the first 3 terms of a GP. I know the second term divided by first term is what we call the common ratio. And it is equal to the third term divided by second term. That's all I've done here. This second term divided by first term, third term divided by second term equals. Then I form an equation, then I solve it until I end up with a equals to a for the a of the original AP. But they are talking about the first term, a of the GP. So you add 6 because the first term of a GP is that one. A that we already have 6 plus 6, you get 12. So that is where the answer is. So all you need to do, my student here, try to work it out. Try to look at this. 27a minus 24a. On the other side you get 3a. Then you have 144 subtract 126, you get 18. You divide by 3, divide by 3. That's how you get 6. And that is it. Then for the same, they're asking you to find the sum of the first 9 terms of the GP. The formula is there, it's at the back of your mathematical table. A into 1 minus 1.5. Yes, what is this 1.5? The common ratio. The common ratio. Because this one, for instance, this is 12. Automatically this would be 6, it will be 18. 18 over 12. That is 1.5. There it is, minus 1 minus 1.5, blah blah blah. That one, you get the answer, the method 1. So that is question number 20 done. Question number 21, a question on vectors. And questions on vectors, my student, they are very easy. So do not fear questions on vectors, because like these are 10-mark question on vectors. So you're given this diagram here. There's a vector PQ, there is a vector PR, a vector QR, of course a point M here, yes, a point M, such that the ratio from Q to M, M to R, 1:2. And of course the point L here, such that the ratio here is 1:3. PL is to LQ is 1:3. So the first question, A Roman 1, we express the vector QR in terms of B and C. Now, what exactly do I need to know? I need the vector QR. QR is given by QP, yes, against that direction, plus PR. That is QPPR. So if that is the case, this is minus B, negative B, plus C, which is the same as C minus B. So that's where the student scores the first. The other vector is vector PM. PM. Yes, that vector. Vector PM is PQ plus QM. So if that is the case, it means it is B. Yes, you can see B here. Then a third. This is 1 out of 3. A third of QR. And we know QR is C minus B. And that's why it is important to get this mark there. Good. With that, if I can reduce this one, I will end up with this. Remember, I can still use the ratio theorem. I need vector PM, so it is 2 over 3 of B plus 1 over 3 of C. It is the same, what I've done. So the ratio theorem is still agree. So I need vector RL. Yes, RL. That vector. I can argue out that RL is RQ, yes, plus Q. If that is the case, it means RQ is the opposite of QR. So it will be B minus C. Yes, the opposite of this one. B minus C. And then plus negative 3/4 of B. And if I'm able to reduce this, it will end up with this. Look at this one. It is 1 minus 3/4 B. That is a quarter B. Then minus C. Remember the ratio theorem again, it will still work. This is B1. So my student, this one is very important. This one is very important. and even the first vector I worked out here is very important. Why do I say that? I will have to use them in the next part. 3 marks, my students, that are easy to get. Moving on to part B, you are given that Px is HPM. Yeah, you're given that Px is HPM, and you're also given that Rx is KRL. You can see that P to X, it is H of PM. That means H is a proper fraction. It's a constant that is a proper fraction. Then we have Rx is K of RL. So with that, again, that is another proper fraction. So the K and H are scalars, or they are constants, and they represent fractions. So what exactly do we need to do? We need to represent Px in 2 ways. You represent it in 2 different ways using the H, B, C, K, all of them. So what do I do? I'm given the first one, I can use it, that Px is H of PM. Already I had the PM somewhere, here it is. So that's all I've done, H of PM, and I open the bracket. Remember, the H should come first before the vector. It is a constant. This is the arrangement, not BH, HB. So this is the first point where the student scores the mark. Then we go ahead. Px is PR. Okay, remember Rx is K of RL. So we want to represent Px in another format. Why is that Px? Px. And in this case, I have to use this. I have to use Rx. So let's look at this. Px, and I have to use Rx. So the best way is to go PR, then Rx. How do I do that? PR is C. Okay. Then Rx, according to the second statement, is K of RL. K of RL. Do I have RL? Yes. Here it is. So it is K. Where is that? K of RL. I only need to open the brackets. Yes, there's a step I've ignored here. Then I do rearrangement, and of course I factor out the vector part of it. It is outside, and this is where the student scores another mark. So my student try to do this, work out this, manipulate the figures, and then whatever you're given here, you end up with this. Having done that, my student, I have represented Px in 2 ways. So I equate them. That is what I've done here. That is what I've done here. That the Px I had before, here it is equal to the Px for the second part. Then I again equate what is before B, the coefficients of B in this case, to the coefficient of B, ignoring the vector part of it. And this is what I've done. That is my first equation, that 2 over 3h is a quarter k. Then I go ahead to do the other one the same. That is a third h is equal to 1 minus k. Why that? Because these are the parts with the c. That's the part with the c, and that's how I get the second equation. And by doing that, my student, you get 1 mark for forming the 2 simultaneous equations. Because of space, I have not maybe gone ahead to solve it, but I have the answers here. What do I do? This pair of simultaneous equation, I can just do that is not elimination as such, substitution. In the first one, make k the subject by multiplying by 4. That is, k is 8 over 3h. Then that 8 over 3h, you substitute it here, 8 over 3h. Having done that, you'll have an equation with just h. So you bring this on this side. Yes, you will have 9. Yes, 9 over 3h. That is 3h equals to 1. Divide by 3, divide by 3, h is a third. You can see h is a third there. Having done that, I can go ahead to get k. Remember, my k was 8 over 3h. So 8 over 3 times a third, you get 8 over 9. And that's how you get this. And for doing that, my student get 1 mark and 1 mark for h. Yes, and I have gotten the scalar h and k. Wow. My student tried to work it out. What does that mean? Remember h, that is px was hpm. Px was h of pm. That means this is a third. The ratio of 1 is to 2. The ratio 1 is to 2. It is a third of the whole. The other one, the same. Rx is k. K now is 8 over 9. 8 over 9, yes, 8 over 9 of the whole line. So this is 8 is to 1. Okay. If that is the case, now we can work out this. The ratio Lx to xr. This is, if I can say negative 1 is to negative 8. The ratio there divided by negative 1 divided by negative 1. So it is 1 is to 8. And that's where the student scores another mark. That is 10 good marks for the question on vectors. Wow. Question number 22 is a question on variations. Form 3 work. And this is what you're given. You're given that x is directly proportional to the square of y. Okay. And x is also inversely proportional to the square root of z. You're also given that x is 12 when y is 24 and z is 36. Okay, remember you have three variables here. So the question is, you find the value of x, yes, when y is 27 and z is 121. So my student, this is joint variation. Not partial variation, joint variation. So how do we go about that? X is proportional to y squared over z squared. So all I've done, my student, is to remove the proportionality sign and then replace it with an equal sign. And by doing that, I bring in a constant. So this is how it will look like. And that is why the student scores the first mark, because as an examiner, I can tell the student has an idea. What I need to do is to replace what I've been given. I've been given the value of x, 12, equals to 24, the value of y, 24 squared, as per my formula here, times k, constant, all over the square root of z, 36. That one I have. If I'm able to do that, this will be 12 equals to 24 times 24k over the square root of 36 is 6. So by doing that, if I close multiply, I get there k to be 1 over 8. So my student just work out that. I have the value of the constant. So next, what exactly do I need to do? I need to come over here and now work out. Remember, I'm supposed to work out the value of x when y is 27, z is 121. So fix y and z. 27 squared, yes. Remember, my constant is 1 over 8. 1 over 8 of root 121, this one. And by working out that, again, my student, you get the answer here, 1. That is part A, and I think it's a 3-mark question. You answer that one, and that one. Yes, 3 marks for part 1. Then you go to part 2. Part 2, the question is very clear, that y is increased by 5%, and z is decreased by 19%. Good. So if that is the case, the y will be 105%. Then z, originally it was 100%. Subtract 19%, you get 0.81, and here it is. Having done that, the first part is squared. Y was obviously in the formula squared. Then I have the 8. 8 was part of the constant. Then this one squared. And having done that, I'll get this. The square of this, it is here, y squared. Then the square root of 0.81, it is 0.9. Z is still under square root. All I need to do, my student, is to work out this part. Forget about 8, it was part of the formula. Key in your calculator and you get 1.225 y squared over 8 z squared, square root of z. Why am I leaving it like this? This was part of my original formula, and without actually including the k, it is the whole of this one. My student, that's what I'm doing, that I'm avoiding too much of the stories. So my original x was k, remember k into 1 over 8, y squared root z. That is original x. The new x, my student, it is the way it is written here. 1.225 y squared over 8 root of z. and there it is. So this is it. I have represented the whole of, without too much of the story on this right hand side. I use the left hand side. So the change in x will simply be minus the original x. Yes, so the whole of this, subtract x, that is x1, and by doing that I get this. So that's where the change in x is. Let's first of all consider the marking in this case. This I can give you 1 mark. If I'm able to reduce this up to this, I can give it another 1 mark. If I go ahead, or the point where I'm getting the change in x, another mark, then the percentage change in x will be the change in x itself over the original x times 100. And the answer of course here, 1 mark. My student, try to go about that. Try to go about it. I'm just offering you a good guide on how to do it. Part B, a totally different question. Y is inversely proportional to the square root of x. I'm given that y is 4. That's x is 4, y is 3. I fix that. 3 equals to k over root 4. If I'm able to get this is 2. 2 times 3 is 6. So k is 6. Then I bring it back. So 6, this will be y equals to 6 over root x. So now I find x when y is 8. Y is 8, constant is 6, root of x that I do not know. Having done that, I can do cross multiplication. Then I do divide by 8 all through. So root of x will be 6 over 8. Or rather, you can say it is 3 over 4. Then I want to find x. Yes, your x on my x here. Square both sides. So it will be 3 over 4 times 3 over 4. You get that. So answer 1. So if I have to mark this, 1 mark, the method 1, and the answer 1. A question on variation. A good question for you, my student there. Question number 23. Statistics. With this one, you're given some masses. Yes, this is grouped data. Some masses in kg, 40 to 49, 50 to 59, all the way to 100 to 109. The frequencies were also given. That for the first group, 9, 19, 22, all the way 8 there. The first question, the student was expected to state the model frequency. That is the highest occurring frequency. Just that. Remember, they're talking about the model frequency, not the frequency, the model class. Get that clearly. So for this one, you consider the frequencies, the highest is 22, and you write it down. That is the model frequency. If they ask for the model class, you will select 60 to 69. But that is a free mark, the first one. Then we do part B. The student was expected to do the mean mass for this data. So what I expect the student to do, I expect to see the column for the midpoint. That is 40 plus 49 divided by 2, 50 plus 59 divided by 2. I expect to see that well calculated. Then for this one, the student was not supposed to use the assumed mean. Yes, or the working mean method. So we are just going to do it directly. So we do fx, f times x. And again, I expect to see all these well done. My student, I expect to see that well done. The f times x. With your calculator, you can be able to even confirm my working here. This one. And then you end up with the total frequency, 100, the total, the summation of fx again, you work it out. Having done that, my student, I expect you to do that the mean will always be given by the summation of fx over summation of f. And that's all I've done. After getting the summation of fx 7170 divided by 100, you get that. And that's where you get the answer 1. 3 mark and 1 mark, well done there. Part C. The student was expected to work out the median. So my total data here is the total frequency 100. 100 divided by 2 is 50. So I go to I need to generate cumulative frequency. 9 plus 0, 9. 9 plus 19, 28. 28 plus 22, 50. All the way to 92 plus 8, 100. So I ask myself, where is the 50th mass? It is here. For this one, coincidentally, I can see the 50 there. So I need to select this class. That is what we call the median class. The class in which the median lie. So it is in here. So how do I go about that? And by generating the frequency, that is cumulative frequency, another mark. Now, we go ahead. Median is given by the lower class limit of the median class, then E plus total frequency over 2 minus cumulative frequency above. Cumulative frequency above the median class, over frequency of the median class, F multiplied by the class interval there. So I have to consider this. This is 60. So this is 59.5, the limit. This is the boundary, class boundary. I need to know the class limit, the lower class limit. And there it is. Then plus 100 over 250. 50 minus 28, yes, over frequency of the median class, 22 multiplied by 59 plus, minus 40. The class width is 10. If you work out that, my student, you get that. And the method, 1. Good. Again, for the median, you have 3 marks. So far, I have 7 marks. So, finally, the student was to draw a histogram. A histogram. And how do we go about that? I can decide to break the x-axis, and of course I have the lower class limit of the first class, all the others are the upper. So over here I have 39.5, the lower class limit for the first class. That's what I start with. Then I go plotting with the upper class limit, 49.5 for all the other uniformly. Yes, and for this case, because the class intervals or the width of the class were all equal, I go direct. Without using what we call the frequency density over here. With that, my student, we start plotting. The first class, the frequency was 9. So I need just to get where 9 is exactly, and then I draw a bar. Okay? The next one, it is 19. So I have to extend that to where 19 is. Again, I do another bar. So remember that is somewhere 19 there. This is 9 there. Okay. Or having done that, I can consider the next one, 22. 22. Remember, I'm just doing a good guide for you, my student. Yes, I'm doing a good guide for you so that you can draw in your graph book. So that is 22, somewhere there. Then 18 is the next, somewhere here. 18. Good. 18. Then the next one, 13. 13, somewhere here. 13. The other one is 11. Yes, slightly above 10. And the other one is 8, just somewhere here. So my student, that is a histogram. A histogram. It looks more of a bar graph, but the bars are together. Yes, the bars are together, and that is it. In case they ask for the frequency polygon, you need to have the starting point here, the lower class limit of the first class, then the midpoints. But this one was not asked in this case. The midpoint of the bars and of course there. So then join them with a straight line. That will be a histogram. That is question number 23. Finally, my student, question number 24. This is a question on probability. Again, I say this one is a game of chances, a game of likelihood. So my student, you don't need to fear the question. However complex it may look like, it is very simple. Now, what instruction are you given? You're given that there is a bag that has 3 red balls, 5 white balls, and 4 blue balls. So 3 red, 5 white, 4 blue. Now, remember, all these balls are identical. Chances of picking any ball, any single ball, are the same. So there's no biasness in this case. So part 1, you're supposed to draw a probability tree whereby 2 balls are picked from this bag, one at a time, without replacement, without replacing the ball. So what exactly does that mean? The chances, when you are picking the first ball, the chances of picking a red ball, it is 3 out of 12 because there are 3 red balls. Okay? Chances of picking a white ball is 5 out of 12. Okay, my student? Yes. Chances of picking a blue ball, it is 4 out of 12. Why do I have 3 branches? Because there are 3 different types of balls in this bag. So the chances are, if I do pick a ball at random, it may be 1. Chances are it may be a blue, white, or a red. So chances are 3. So we have the 3 branches. So that is the first picking, and already I have a mark for the first round. Now, I have removed 1 ball without replacement. Assuming that the first ball was red, so the red balls have reduced by 1. So in the second picking, I have chances of picking a red one being 2 out of 11. Remember, even the total number of balls has reduced by 1. So it is 2 out of 11. Chances of picking a white in the second picking, having picked red in the first one, the whites are still 5, but the total number of balls are 11. So 5 out of 11. Chances of picking a blue one, 4 out of 11. Again, the number of blue one, if I have started the red, they are still 4 out of 11. The second one, cases where I picked white in the first picking. So picking a red, it will be 3 because they are now 3, it's still 3 out of 11. Picking a white, remember there were 5, now there will be 4. So this is 4 out of 11. Picking a blue one, they are still 4 out of 11. The last chance here, if I started with a blue, so picking a red, it will be 3 because they are still 3 out of 11. Picking a white will be 5 out of 11. And then picking a blue one, having picked a blue, it will be 3, 1 less of 11. So by doing all this, I get another B1. Remember these 3 branches, the total probability must add up to 1. And by drawing the tree, you have 2 marks. Now, remember I can have all these probability space. All these are the chances. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 different chances in case I pick 2 balls without replacement. So how are these? I can pick a red and a red, a red and a white. I can do a red and a blue. I can do a blue, a white and a red, a white and another white, a white and a blue, then a blue and a red, a blue and a white, a blue and a blue. No chance in this case are the same. They are all different. This lists all the possible chances. Now, I'm supposed to use my tree to solve the following. The probability that I pick 2 reds. If I consider all this, I only have 1 chance of picking a red. And the way I've worked out this, it is simply, if I'm following the tree, those are independent events. So I have 2 over 12 times 2 over 11. And that's how I get 6 over 132. That is it. That's what I've done here. So actually this should be a 1 mark. It's just 1 mark. Because it is 2 times 3, 6, 11 times 12, 132. If I simplify 1 over 22, it is still okay. Moving on to part C. I'm supposed to find the probability of picking only 1 red. Get that, my student? Only 1 red. So let me go where I am getting only 1 red. For instance, this one, there's only 1 red. Over here, there is only 1 red. Over here, there's 1 red. Over here, there's 1 red. However, in this one, there are 2 reds. So I don't go for that. So I have a red, white, a red, blue, a white, red, and then a blue, red. So if I can consider that, this is 15 over 132, 12 over 132. Remember what I've done with this? I've just followed that branch. Like this is 3 times 4, 12 out of 132. Of course, I multiply those fractions. Then I'll have 15 out of 132, yes, and of course 12 over 132. And by doing that, the method is a mark and the answer is a mark. All the student need to do is to add the fractions. And with part D, the student is expected to find the probability at least there is a white. At least there is a white. So let's go to where at least I can see a white. Over here I can see a white. Over here I can see a white. 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 1, 2, 3, 4, 5. Yes. So with that I can just add 15 over 132. Yes, plus another 15 over 132, plus 20 over 132, another 20 out of 132, and another 20. I'm sure, yes, 20, 20, and 20. 20 over 132. By doing that, a method 1, yes, actually a method 2, that should have 2 methods. It is a bit longer, and then the answer 1. So 3 mark there, my student. The last one. The probability that the 2 balls that are picked are of the same color. So how do I go about that? It is either red red, it is either white white, or blue blue. That is it. Chances of the same color, there are 3. So either 6 out of 132, or rather 20 out of 132, or else it is the last one, 12 out of 132. By adding up that, method 1, and the answer 38 over 132, otherwise it can be 19 over 66 for a mark. Good. So my students, we have gone through the whole paper. So this is one of the best papers you can interact with and learn mathematics. So my student, don't fear mathematics. Handle it with a lot of ease there. Otherwise, thank you so much. God bless you.